graph between potential energy curve is potential energy and x curve or displacement curve. So potential energy versus displacement curve. Potential energy versus displacement curve. Okay, so we draw the potential energy versus displacement curve, and what we can interpret from this. So suppose we have this kind of graph. So this is displacement x or s, and this is potential energy u. Okay, so graph can be like this. Okay, graph can be like this, and this is very much similar to the a surface on which we have some higher and some crest or some trough. So suppose consider a region where we have mountain. Okay, so at the top of mountain, suppose you are climbing on the mountain. So suppose you are climbing on the mountain, suppose you are going from here to here. If you are climbing on the mountain, okay, so that is equivalent to what? Increase in potential energy. So suppose we have point A, point B, point C, point D, and point E, and point F. Okay, on a track on a earth surface. Suppose we have this track on a earth surface. So if we are moving from point A towards point B, so that is equivalent to climbing of a mountain. Okay, so climbing of a mountain means it is what? This is the increase of gravitational potential energy. So the potential energy versus distance or displacement graph, the potential energy versus displacement graph, you can compare with the surface on the earth. If you are moving up on a earth surface, so you are increasing the potential energy. Okay, at the top of mountain, you have the maximum potential energy. Okay, then now if you are suppose going down from the mountain top, so if you are going down from the mountain top, you are having decrease in potential energy. Okay, so decrease in potential energy. Okay, so as you are going down, decrease in potential energy, and when you reach the trough, okay, so this is trough means lowest point. When you reach the point D, here again there will be no force, or we can say the potential energy is minimum. At point D, the potential energy is minimum. Okay, then if you move again, suppose we are rising, the potential energy is zero. Sorry, potential energy is increasing again at point E, and at point F, the potential energy is not changing. It is equivalent to a flat surface. Okay, so point B is equivalent to top of mountain. Point D is equivalent to the lowest point near the mountain, that is trough. So this is called crest, this is trough. And point F is a point on a plane region. So on a flat surface, suppose you consider a flat surface or a plane region, you would have studied in geography. A plane region, we have no slope, so there is no slope here. And at point A, C, and E, the slope is changing. At point A, C, and E, slope is not changing, but what we can say is the potential energy is changing. Okay, increasing or decreasing. So what we can write about this point? So A, about point A, what is A? A is potential energy increasing. Potential energy increasing. So what will be du by dx? Du by dx, the rate of change. See, if now we can relate it with in terms of slope. So du by dx is the slope of this graph. So slope should be positive. The slope is positive here. Okay, slope is positive. At point B, B is the maxima point. At maxima, what is the slope? Is it 0? U is maximum or maxima point. So the slope at this point is 0. The du by dx is 0. Then at point C, u is decreasing. So du by dx is negative. Okay. At point D, u is minimum. u is minimum, so du by dx is again 0. Okay, at point E, u is increasing, so du by dx is again positive, and at point F, u is constant. Constant means again du by dx is 0. Okay, so what do you know? How do you relate du by dx with the force? So we know that the force is minus du by dx. So that we know that from our previous lectures, we know that the force is negative of displacement of potential energy. Okay, we were calculating this. So if potential energy is the rate of change of potential is 0, means at this point, and this point, the force should be 0. So F is 0 here, and F is 0, it means these points are called equilibrium points. Equilibrium points. These 3 points are called equilibrium points. Okay, so we have these 3 points as equilibrium points, and why? Because du by dx is 0. Now look at the practical situation. So suppose you are at the top of the mountain. So at the top of the mountain, there is no force. So when you are on the side of mountain, you have a force acting on you, a downward force. If you are unbalanced, if you are not able to balance yourself, you will fall down from this side. Okay, you will fall down. But at the top, you can easily sit. So that we know that Lord Shiva is what? Residing at the top of Kailash Parvat. Okay, so at the top you can stand. At the crest also, at the trough, at the lowest point also, you can easily stand here without applying any force. But if you want to remain at point A, C, and E, you cannot remain at these points without applying any external force. You cannot remain at this point. Suppose you take a ball and keep the ball at different points. So if you keep the ball at point A, that will slide down in backward direction. If you keep the ball at point C, that will slide down in forward direction. But if you keep the ball at point B, the ball will remain at this point. It will not experience any force. If you keep the ball at point D, here also the ball will remain at this on position. And if you keep the ball at point F, the ball will remain at its on position. So these 3 points does not experience any force. So you can keep any object at these 3 points, and the object will be in equilibrium. It will not experience any force. Okay. But at point A, C, and E, there will be a force on the object. Now we